Let's get into monosaccharides. So first, let's expand on the definition of a monosaccharide that you put in your 20.1 notes. In addition to everything that I've already said about monosaccharides, let's expand our definition to say that it is either a ketone or an aldehyde with 3 to 6 carbon atoms. And I told you that 6 is the most common. And in this monosaccharide, every one of the carbon atoms is going to have either a double bond to an oxygen, so carbon-oxygen double bond, and that will be the ketone part or the aldehyde part. Or if it doesn't have that, it has a bond to an OH. So every single carbon atom has an oxygen on it. Monosaccharides can be classified as either an aldose or a ketose. In the aldose molecules, the aldose monosaccharides, the carbon-oxygen double bond is on the first carbon, carbon number 1 of our chain. And so it is an aldehyde. And we'll draw a picture of that. In the ketose molecule, the carbon-oxygen double bond is on carbon number 2. And so it is going to be a ketone. So let's draw a couple of pictures. Now remember when we drew one of these before, when we draw monosaccharides, we draw them up and down vertically, which takes up a lot of space. So this is going to be a 4-carbon chain. The carbon on the top, carbon number 1, is going to have the carbon-oxygen double bond. And even though in section 20.1 I told you that down here at the end of the chain we normally draw this part of the monosaccharide in condensed notation, I'm expanding it out for this in this particular drawing. So this would be an aldose. With our carbons, when we number them, we start at the top and we number down to the bottom like this. So our carbon-oxygen double bond is on number 1. It's an aldehyde and it's an aldose. Let's draw a ketose. So again, we're going to have a carbon chain. This one's going to be a 5-carbon chain. And since we're drawing a ketose, we want to put the double bond on carbon number 2. We'll fill those numbers in a second. And every other carbon atom has to have an OH. So we'll fill those in, and then we'll add hydrogens as we need to make sure that every carbon has 4 bonds. And let's put numbers on our carbons. There's 1, 2, 3, 4, 5. I left a hydrogen off of carbon number 5. So there's our ketose with the carbon-oxygen double bond on carbon number 2. So in addition to classifying a monosaccharide as an aldose or a ketose, we can also classify it based on how many carbon atoms it has. So if it has 3 carbon atoms, whether it's an aldose or a ketose, 3 carbon atoms, we are also going to call it a triose. Ose is the suffix for sugar or carbohydrate. So triose, tri meaning 3, and the ose telling us that we're looking at a sugar molecule in general. If we have 4 carbon atoms, we will call that a tetrose, where TETR is going to be our prefix meaning 4, and ose is our suffix telling us that it's a saccharide. If we have 5 carbon atoms, we can also call it a pentose, pent for 5. And if we have 6 carbon atoms, we can call it a hexose. And these names, triose, tetros, pentose, hexose, they apply to both the aldoses and the ketoses. So for our two molecules, like in looking at this guy right here, if we wanted to describe this, we could call it an aldose, and that would be correct, and it would be kind of a generic name because when we say aldose, the only thing that we're communicating in that name is the position of the carbon-oxygen double bond. If we wanted to be more specific, we could call it an aldotetros. The aldotetros name, the aldo part is telling us that it is an aldose, and the tetros part is telling us that it is a total of 4 carbons. So this name is a little bit more specific, but it's still not really all that specific. It's still kind of a generic name. Looking at our other molecule over here, if we wanted to classify this molecule, we could say that it is a ketose. When we say that it's a ketose, all that we're really saying is that we have a carbon-oxygen double bond on carbon number 2. We're not saying anything about the entire molecule. We could also call it a Keto Pentose. This name is a little bit more specific. Keto means that it's a ketose, and the pentose part is telling us that it has a total of 5 carbons. So that name is even more specific. However, these names, these 4 names that we've come up with, the ketose, the aldose, the aldotetros, the keto pentose, those names are also still pretty generic because there are multiple ways in which we could draw a keto pentose by changing the position of the OH groups in this molecule, whether we're drawing the OH group on the right-hand side like we did here, or we could also draw it over on the left-hand side. So as we get more specific with our molecules, we'll come up with even more names to be able to describe them more accurately. But these are the generic classifications of monosaccharides.